So here, finding the missing dimension. Really, what we're looking at is we're looking at this piece here goes with this piece here because they go up to that line. If we slide them together, we're basically getting a triangle like that where this is 1.0, this is x. This is a right angle. Then we have this here, which is the 2.83, corresponds to that piece. If I slide those together, we have a big triangle, 2.83 here and 2.0 here. And that's right angle. So as Josh said, we either go x is to 1 as 2.0 is to 2.83, or we can go 2.0 is to x is 2.83 is to 1, either way. And we can cross multiply and divide. 2 times 1 divided by 2.83, which gives us 0.707 is x. Any questions? Now, coming up on Monday is our Unit 1 test. Questions like this you will be expected to know. Questions like our Morris taper question, I won't put on the test just for sake of time. But you will be required to remember how to do tapers. I might give you something like this. Say this diameter here is 2.25 inches. And this taper is it's 2.75 inches per foot. And I should find the length for that. Remember, taper, big D minus little d over L over 12. Here, T is 0.75, we know that. Big D is 2.25, big diameter, right? Little d is 0. And we are looking for L, so you'll be solving this. A lot of different ways you can go about it. We'll do Josh's preferred way, which is to multiply by the L over 12. So multiply by L over 12 on both sides. So this is gone. Over here we just got 2.25. 2.25 minus 0 is 2.25. L over 12 times 0.75. So 0.75 divided by 12 is 0.0625. Now we just divide. So it's L times 0.0625. So to get L by itself, we got to divide by the 0.0625. So it's 2.25 divided by that. 36. So length is 36 inches.
Hold on. Multiplied L over 12 times 0.75.
Yep.
Divide 0.75.
So this is, 0.75 divided by 12 gives you this.
Divided by 12 equals
No.
whatever.
What I did is I multiplied the L over 12 times the 0.75 over 1. So I've got L times 0.75 over 12, right? Because 12 times 1 is 12. So I divided out the 0.75 divided by 12, give me the 0.065. Or you could take the 2.25 times 12 and then divide it by 0.75. You could do that.
No, so you get rid of the L over 12.
Yep.
L over 12 times 0.75. Divide 0.75.
Divide by 0.75, okay.
So you get L over 12 equals
3.
And then you got to
Multiply by 12. Yeah.
Yeah.
That would work too. Or I might ask you other taper problems where if I tell you that this is 1.8 inches, this is 9 inches, and this is .8 inches per foot. Find D. So do the same type of thing. Taper equals big D minus little d over L over 12. So 0.8 goes in for T. 1.80 goes in for big D. We're looking for little d. 9 over 12 down here. So I'm going to multiply by the 9/12. Now I'm just going to multiply this out. 9/12 times 0.8 is 0.6. And then solving for little d. The key here, since that's minus d, I'm going to treat that as a negative 1d. So I'm going to subtract the 1.8. This is negative 1.2 equals negative 1d. And just divide by negative 1. So d equals 1.2. Make sense?
So how yeah, it does.
Okay.
Can you go back up?
Yep.
Quick? Up. Right there.
Okay.
So how can you just assume, or how can you just multiply the L times 12 to the 0.75 and not combine 0.75 L? How can you just combine the 12 and not the L?
Okay. So what you can do is you get L times 0.75 on top is 0.75 L. You can get that.
You're just leaving that out because you know.
Yep. Then you have to divide it out, but you can't divide the L by the 12, so it's just 0.75 divided by 12 is 0.0625.
Right.
L.
Multiply the 12 and divide by the
Yep.
75. Okay. You're just shortening it up.
Yep.
Yeah, but I thought it was like
Okay, so let's assume there's an electrical motor on this gear. What is my gear ratio? Yep. Driven over driving. So that's going to be this one goes on top, right? So figure this is 12 teeth and that's 16 teeth. The ratio's 12 over 16 or 3 to 4. If I tell you that the motor operates at 600 RPM, what's the RPM on the driven gear?
16 times 600.
There you go. It's size times speed. It's not a ratio anymore, it's a product. So yeah, 16 times 600 divided by 12, which is going to be 800 RPM. Make sense? So I want you guys to try this one in your notes. So we have this pulley system here. I'll tell you this first pulley here is operating at 360 RPM. Find the RPM of this last pulley. give you a few minutes, see if you can figure that out in your notes. Okay, so tell me what to do first. Okay, 8 times 360 equals 5 times, we'll call that A, will be the speed of this one. So 8 times 360 divided by 5 is correct. Which is going to give us 576. So it's 576 RPM on that little gear. Okay, good. The big gear, the 20, has to be moving at 576. So 20 times 576 equals 9 times, we'll call that X. So you got 20 times 576, or 576 times 20, divided by 9, 1280. How many of you had 1280 for that? Good deal. These are on the same shaft, so the 5-inch and the 20-inch have to be moving the same speed, the 576. So that's why we just took what we got for A here, which is the 576, and plugged that in with the 20. Find the overall height of this piece. I'll give you a minute to do on that. So, first thing we want to do is find the distance across there, which is going to be what? 28. So then we're looking for this height that we can add to the 42. I'm going to call that A for now. What are we going to set up for our proportion? Careful. 3 over 2. A over 28. There we go. So 3 times 28 divided by 2. A is 42. So this is 42 here. So X must be 84. 42 plus 42. Find X in this one quick. Okay, so for this one, we have to be able to find, we're dealing with this triangle here that I've outlined in blue. We have to be able to find at least one of the dimensions of that triangle. Either the horizontal or the vertical. Which one can we find? This one right here, horizontal. It's 35. 50 minus 15 gave us 35. Now that we have that, I'll label this dimension here A. I can find dimension A. How do I find it? 3 over 5 equals A over 35. Then we cross multiply and divide. A is 21. So what do we do with the 21 millimeters? Subtract it from 40, x is 19.
Do you actually have a pen up there, or are you just writing with the mouse?
Still stylus.
Oh, okay.
I use the mouse for some stuff too. So if I give you the area of the bigger one, obviously this is the big one's an enlargement of the little one. If I give you the area of the big one is 180 square inches. Find the area of the small one. So of course we start out with the ratio of lengths. What's the ratio of lengths here? 8 to 12 or 12 to 8. Reduce the 2 to 3 or 3 to 2. So to deal with areas, that 2/3 becomes squares, 4/9. Where's the 180 go? On bottom. And we will cross multiply and divide to get 80. Good. So then,
Why are you whispering at me? Did you not get it? Okay. Yeah. You say cashmere?
find the volume of the small one there. So what's my ratio of lengths? Okay. Now we got 15 to 20, which will reduce to 3 over 4. So you were about jumping ahead to the ratio of volumes. 3/4 is going to be cubed. So it's 27 over 64. 3,200 goes on bottom. Cross, multiply, and divide, we get 1,350. As long as you keep them matched up. Yeah, you could have 20 over 15, but then the 3,200 would be on top because it goes to 20. Yeah, it should work out the same. Any questions? At this point, you should be adequately prepared for the test coming up on Monday. Is there any questions out of the packets or anything else that you have questions on that you want me to go over? 78 on the packet. Piece of bronze has a ratio 10 to 1. The 10 is copper. The 1 is tin. That's 78. Oh, look at the second 78. Gotcha. The other 78. On a trial production run, on a trial production run, 22 parts are produced in 4.5 hours. So that's just going to be a rate, 22 parts in 4.5 hours. The same rate, how long to the nearest tenth of an hour does it take to produce 1,600 parts? So 1,600 parts goes on top, cross, multiply, and divide. So 4.5 times 1,600 divided by 22, here's 327.3 hours. That's it? Sure. Did you have one you wanted to see, Josh?
Yeah. The 43.
43?
Yep. I meant to put 0.05 on my paper too, not 0.5.
That'll make a difference.
Okay, I think it's wrong.
Yeah. So number 43, you want to see one like that?
Yeah.
See if I can come up with one that's reasonable here. I'm not going to do 1-to-1 this time because we've done that. It's boring, and we're going to try something different. So we're going to do 3-to-2. I'm going to tell you that this depth here is 0.200 inches. We're going to assume all our dimensions are in inches, so I don't have to add inches anymore. From here over to here, actually, I'm going to make this easier on us. I'm going to make that 0.300 inches. From here over to here is going to be 2.5 inches. Oh, let's see here. The ball is going to have a diameter of 1.8 inches. Let's see where that takes us. I want to know how high it sticks up above the surface. First thing I can find is I can find this distance here pretty simply. Because I can find this distance here pretty simply. Because if I think of this as being a triangle, I've got my 3/2 equals 0.3 over, I'll call that y, over y. Cross multiplying and dividing, that has to be 0.2. So if that's 0.2, this is 0.05. Put my decimal point in the wrong spot. That should have been 2.5. Let me change that. It's 0.250. That's what I get for making up problems on the spot. That should be 0.250 there, not 2.5. So now we need to start working with this ball here. We know that from the center of the ball over here, that should be where the point of tangency is. There's at a right angle. I just didn't draw my ball real round. That has to be 0.90 inches. Has to be our radius, half the diameter. We know from the center of the ball down to this surface, has to be 0.90 inches. So what I'm going to do is I got to create a triangle with that as the hypotenuse. I have a horizontal piece and a vertical piece here. You create that triangle. So now we're going to zero in on that triangle for a minute. Now this surface that it contacts at a right angle has an aspect ratio of 3:2. If you recall from last semester, we talked about if two lines are perpendicular, what happens to their slope? If they're parallel, they have the same slope. If they're perpendicular, it's the reciprocal, opposite reciprocal. This one's positive, this one's negative. That don't matter here. We're just worried about the aspect ratio. With the perpendicular line here, the vertical and horizontal switch. The rise and the run switch places. It's reciprocal. So this was a 3 vertical to a 2 horizontal. This is going to be a 3 horizontal to a 2 vertical. Does that make sense? So this is the one that applies to this triangle. So now I'm going to take this aspect ratio here. We're going to work with it a little bit. I'm going to slide it up here so I got some room. In order, what we know about this triangle is that this hypotenuse is the radius of the circle, 0.9 inches, 900 thousandths of an inch. Well, in my aspect ratio, all I have is vertical and horizontal. The 2 corresponds to this side, and the 3 corresponds to this side. Neither one of those 2 correspond to the 0.9. So we have to force it. We have to manufacture a side. To do that, we're going to complete the triangle in our aspect ratio here. So now I've created a complete right triangle there. The hypotenuse of this right triangle is just a squared plus b squared equals c squared. Or the square root of 3 squared plus 2 squared. So it's the square root of 3 squared plus 2 squared, which is 3.606, we're going to call that. Now let's stop. Do you see where I got the 3. Any questions on where I got the 3.606? That 3.606 corresponds to the 0.9. Those are both the hypotenuse of these corresponding triangles. Now I'm going to call this A and this B. A, of course, is going to go with the 0.9. It corresponds, because it's vertical, it corresponds to which side up here? 2. A goes up and down, 2 goes up and down. So we cross multiply and divide. Oops. We get 0.4. Oops, hold on. 0.499 is A. A here is 0.499. B is going to be found the same way. 3.606 over 0.9. B goes to 0.9. What goes above the B? The 3. B is 0.749. So what does that do? Takes us back to the original picture. So what we have, the distance from here to here, from right here to right here, where this is tangent, is the 0.9 plus the 0.749. So that's 1.649 inches. Subtract the 50. This ain't gonna work out, is it? I get 1.599 inches. I had decimal points in wrong spots all over the place here. This should have been 0.18, not 1.8, but we'll live with it. So anyway, 1.59. By subtracting this, that tells us the distance from here to there. We subtracted the 50 thousandths. Once we have that distance, then we can find this height using the 3/2. So from here down to here, we've got 3/2. The 1.599 is horizontal. Cross, multiply, and divide to get that vertical distance. So that gives you from here to here. So now what you do is to get the distance all the way up to the top, you add this one, you add this here, the 0.499 to get from there to there. Then this is another radius of 0.900. Gives you the distance from here all the way up, and you subtract that distance to get X. I'm not going to finish it off because the numbers aren't going to work because the ball doesn't actually sit down in the groove.
It seems like, I don't really care about trigonometry, but it seems like that'd be an easier, quicker process.
When we get to trig, the trig itself does not shorten that problem up not a lot.
It does shorten it up.
It does shorten it up some. Okay, any other questions? Just to put your mind at ease, I won't do that one to you on the test.
Extra credit.
Actually, if you guys are looking for extra credit, number 44 and 45 out of the packet you can do for extra credit. Number 45 especially is a fun one.